slide, we'll be discussing MATLAB, which is an important data analysis and its importance put across several disciplines.
Next week. Tapi maksudnya abang nak kena bayar loan tu cepat. Oh. Okay. Lepas tu kita abang tu macam mana?
Syaziana.
Kejap, nanti aku call balik. Okay, bye.
Mute.
Okay, so let me go on now. So as I was introducing the session, looking at MATLAB, which is an important software, is an data analysis software, and its usage put across several engineering disciplines in electrical, in mechanical, in chemical, and other areas of engineering disciplines. So today, our distinguished speaker, in person of Dr. Saharudin, Haron, will be taking us through some of the basics of MATLAB. Now, just give a brief intro into he is a senior lecturer of School of Chemical and Energy Engineering, as I earlier mentioned, University Technology Malaysia, Johor Bahru, Malaysia, and he had his bachelor degree in chemical engineering in UTM, same for his master's degree also from UTM, and he had his PhD in optical biosensor at Sheffield Hallam University, South Yorkshire, United Kingdom. Now, before we proceed to the sharing session, and before I hand over the mic to our distinguished guest, I would like to announce some important meeting etiquette that all participants are advised to obey. Now, my name is Muhammad Raji Abdulwasil. I'm the moderator for this sharing session. Now, before we begin, here are some meeting etiquettes that all participants must follow for us to have a smooth session. Please, you are advised to remain muted throughout the event unless you are asked to unmute. Please do not interrupt when the panel speaks. Question and answer session is arranged after the presentation, so just put down your question and you can submit it in the chat box as the session progresses as well. Registration can also be done now. The form for those that have not registered initially will be shared in the chat box, and kindly do so in good time. Similarly, please use the chat box properly to avoid redundant messaging. If there is any important link, that will be shared with all participants in the chat box. At the end of the session, remember to complete the e-questionnaire that will be shared in the chat box, and a QR code of the questionnaire will also be shown on the slide. Your feedback will be highly appreciated. Similarly, at the end of the session, kindly wait for the photo session. It is very important for our record. Thank you for your anticipated cooperation. Now, as I said earlier, MATLAB is an high-performance language for technical computing, great computation, visualization, programming in easy-to-use environment. Now, this workshop is significant because we are expected to understand how to use MATLAB with our distinguished speaker as our guest. As I've introduced our distinguished speaker, without further ado, Thus is an honorable guest to share his insights and know-how on how they are required to become an articulate MATLAB user. Dr. Saharudin, I hand over the sharing session to you. And share your slides with us. Thank you very much for sharing time out.
Oh, yeah.
So,
Yeah.
okay, thank you.
So I can start, Muhammad?
Yes, I can hear you now.
Okay. I can start now?
Yes, yes, you can go on. I've done the introduction.
Okay. Thank you, Muhammad, because I cannot hear you clearly just now. Sorry. All right. Okay. Assalamualaikum and good afternoon, everyone. Right. I can hear Muhammad says the rule just now. You cannot interrupt, right? But it's okay to me. If you have any question, you can interrupt. Okay. Okay, interaction.
Okay, you can go ahead.
All right. Okay.
You can go ahead.
Okay. All right. Okay, you can hear me now?
Yes, I can hear you.
All right. Okay. Okay. So finally, after 3 times, we postponed the date, right? And today we have the session. Okay. You should change the speaker, right? All right. Okay. Never mind. So this afternoon I prepared something special for you. Okay. First of all, let me share with you my slide. So this is my slide. You can see my slide, right? So I put in a slideshow notes. Okay, why I mentioned I prepare something special for you this afternoon? Because we're going to talk about, we're going to discuss about this data analysis, right? Okay, but if we talk about data analysis, it's not something like for the beginners. Huh? Normally it's for the intermediate or for the advanced. Okay? But I was told by Muhammad earlier, somewhere in June, some of you never have experience using MATLAB. Okay? Is it true? So if you are never using MATLAB, so we need to go step by step. We need to learn fundamental about MATLAB, and then we learn about how to do programming using MATLAB. Then we discuss about the data analysis. Okay, but this afternoon, I prepared something special for you. So without level intermediate or advanced, you can do this data analysis. Okay? So we're going to use some function and tools with less coding, right? Because I know most of the students afraid to do this programming, because they're not sure about this coding. Right? Okay, so let's start this one. Hopefully you can learn something and you can do the data analysis without do the complex programming. Can hear me, right? Clearly?
I can hear you.
All right, good. Okay, next one. This is my introduction. Okay, to give you overview about what we're going to discuss today. So, of course, when you attend this course, what data analysis, you have the data, right? Then you want to, when you have the data, of course, you want to visualize your data, right? Something like this, okay? You want to see the pattern or you want to see the distribution of the data, right? How the dependent variables, okay, this y exists, Okay, variables in the y-axis change when there is a different value of the independent variables, right? Of course, this one you can do in the Excel, right? Okay. Then next one you want to know, okay, the relationship between the dependent and independent variables to do this model, right? Yeah, and this one is something difficult to do with MATLAB, with Excel, okay? But I will show you this afternoon. It's easier to do with MATLAB. Okay. So when you have the data, so we can get the equation or the model. We call it the model that can fit the data. Okay. This one you want to do, right? Is it the purpose you attend this workshop this afternoon? If yeah, then it's good. And after that, after you get the model, of course you can get the new data. Okay, you can determine the unknown data that you don't have, okay, from the experiment, for example, and then you can generate more data, right? Like this one. Okay. These are screenshot, right? I take from my screenshot. And of course, after that, you want to have a figure, right? Figure to put in your journal article, right? Q1, Q2, scopus, right? Okay. And hopefully after this, you can generate more figures and then more papers, right? And of course, you want to write something to share with your friends or share the progress report to your supervisors. So you can also do in Excel, no, in MATLAB. Okay. And then publish as this HTML file or PDF file. So we will see this this afternoon. Okay. And but before that, before we can do all this, of course, we need to know how to load the data. Okay. For example, you have data in Excel or in text file or in hard copy in your logbooks. So first of all, before you can do the data analysis using MATLAB, you need to load the data in MATLAB. Okay, so this is a learning outcome for today's course. Someone say something. Everything okay? It's okay.
Yes, I can hear you.
Right, okay. Oh, my flat line is not okay. Okay. So this is learning outcome for today's session. First, I hope after this session you can be able to load the data into MATLAB. Then you can visualize and explore the data, get the equation you want that can fit the data, okay, and then generate more data. You can do the interpolation or extrapolation, okay, from that model. Then write simple documentation to share with your friends or your supervisor, or put something in your journal article, right? Okay. So next one is this one. Okay, I conduct this session based on example, okay, or case study. I call it case study one. This case study. First one is case study one. For example, this one, say you have the this data from your experiment, okay, and you want to get the model that can fit this data and predict whatever value of heat capacity CP for any value of this temperature. Okay, so let's say you have this one, and so how to do this analysis using MATLAB. Okay, when you open the MATLAB, if your first time using MATLAB, you will see this interface. Okay, this is a standard interface or default layout. Default layout in MATLAB version R2021A. Okay, I just download and install a few weeks ago. Okay, now as a UTM student, you can get this free, right? You can download and install. Okay. Using your, you have to create your MathSource account using your graduate email, using your UTM email, okay, and then you can download. Okay. And also you can view many online videos about MATLAB. Okay, when you first time open this, you will see this. I call it environment or desktop. The first, the heading, this one, the top one, you have these three tabs: home, plots, and apps. Okay, so this home and this one, all this is the tools in home tab. And when you click plots or apps, it also has the other tools. Okay, but when you click the tab home, plots, or apps, these three boxes will remain. The only change is the tools inside the tabs. Okay? So this layout will remain. If you want to change the layout, you have to click this layout, and then you can change the layout. Okay? So I just want to mention about this one, this three box. This is a very important box. Call it box or hello. Okay. Or Windows. So the first one is the command Windows. Okay. This is a very important Windows. Okay, when where you want to run any script file or function file, if you create a MATLAB program and then you can save in .m, okay, we call it M file. So there's a script. There are two types of script file or function files. So if you want to run the file, you need to write the names of that file in this command Windows, or you can create variables in this command Windows, and any other commands that you want to MATLAB execute, right? So you need to use this command Windows, and then this current folder is where you put all the files. Okay. If you have script file or function file you want to run in MATLAB, it must be in this current folder. Okay. That if you create the script, okay, let's say you have myscript.m, so myscript.m must be in this current folder. Then you can run in this command Windows. You can type myscripts. Okay. If it's not in this current folder, if you type my scripts, you will say unidentified variables or unidentified files. Okay, and this one is a workspace column or workspace windows, where you will see the variables or the object, okay, with a value. If you have variables a here, for example, you can type in command Windows a equals to 1. Okay, then MATLAB will take that one is a variables with value 1, then it will store in this workspace. Okay, then here you will see the name a and the value is 1. Okay, so this is in general about this layout. Okay, and we're going to use a lot of these three boxes later. Right? Okay, so back to our example. Okay, study one. This one, we have this situation. We have this data. So how are we going to load this data? Like for example, you only have this in your logbook, not in Excel or text file. Okay. So if you only have in the hard copy, you have no choice. You have to use this command windows.
Okay, Kasam.
Hello? Yeah, Damagum.
Oh, it's okay. It's okay.
Okay. Okay, you have to use this command windows. Create your variables, to create your variables, to load your variables, to load the data, okay, to become your variables. So let's say like this, you have type T. For example, you want to have a variables T to store the data for the temperature. Yeah. All right. You want to store this data, okay, temperature, okay, these T variables. All right. Okay, this is how you load your data from the hard copy. So you have to type in the command windows. So T equals to this one bracket and this one not normal bracket. I call it square bracket. Okay, -50. To the T. This is the temperature, right? If you look back, okay, the temperature -50 until 110, maybe in degrees Celsius. Okay. So you have to type in the command windows like this and then enter. Okay. So when you enter, MATLAB will put the variables. Okay, your variable will appear in the workspace here, down here. T and then the value. And same thing to this CP, right? CP equals to. Okay. So I mentioned this one is if you never use MATLAB, okay? So if you already use MATLAB, you know how to do this one, right? So CP equals to square bracket and then the value of the CP space. Okay, for every value you can put space or put comma for different value. Okay, space or comma, and then enter. Okay, close the bracket, enter. Okay, and this CP will appear in the workspace and also the value. Okay, later you can double click this. And you can see new windows will appear to show the variables and its value. Okay, if you put semicolon after this bracket, after you close the bracket and then you put semicolon, okay, comma with dot. Okay, MATLAB will not display these variables. Okay, this variable will not be displayed if you put semicolon. We'll show next prompt, next arrow, next double arrow. Okay. If you don't want to display these variables in the command windows, after you write the variables, after you create the variables, you put semicolon after the close bracket. But in workspace, it will appear there. Okay. It will appear here in the workspace, T and its value. Okay. Only it will not display again. Okay, next, after we have this variables, okay, with the data. Okay, now you have load the data. Okay, so we have fulfill one CLO. Okay, and later we have the exercise. Next, how to visualize. Okay, if you know the command, you can type plot. Okay, the common function to create a figure or graph in MATLAB is plot. Function plot. We use function plot. Okay. If you know this, then you can type plot, then bracket, normal bracket, and after the bracket, if you pause for 1 or 2 seconds, this box, this helps box will appear. Okay. It will guide you what should be in the bracket. Okay. For example, like this, X, Y, and then the other properties. Okay. So you know your x and y, right? You want your x is t, and then CP become your y. So you just type t comma CP, okay? And then enter here. If you enter, then a figure window will appear. Okay? Figure window will appear and with the plot. But let's say you don't know, you are first time, you never use MATLAB, just install or never install, not yet install. Okay, you don't know the function plot. Okay, you can look at this tab, plots. Okay, so I don't want to use this one. Let's say I don't know how the function plot. Okay, so I click this tab plots. So when you click this tab plots, you will see the many function to plot a graph or diagram. Okay, for example, this one plots as this one plot as multiple. Okay, area, bar, scatter, right? Okay, but before you can select which one function, you need to select the variable. Okay, you see here, you mentioned no variable selected. Okay, so you need to select these two variables. Okay, just click. If you want to click more than one, you hold the shift button and then click. Okay, so you click, hold shift button, and then you click TCP, enter. Just highlight that one. Okay, enter, and then you will appear here. Right, CP and T. Okay, and then you can select any tools here. Okay, any function here. Let's say for this one I choose plot. Okay, choose this one, plot, and this figure windows will appear. This one I mentioned just now. Okay. Is this something new to you? Or you already know this one? I hope some of you are something new. I hope. Okay. Okay.
It's not difficult, but I don't understand the way you are doing it for now.
Again?
It's not all that difficult, but for now, I don't understand the way you are plotting the graph.
You know, right?
No, I don't understand.
You don't understand?
Yes.
You don't understand how to plot the graph?
Yes.
Okay. Just click this. Okay. After you select the variables, you just click this plot. Okay. Later we have the exercise. If you already installed the MATLAB, okay, later we have exercise. I need volunteer. I mention later, right?
Okay.
Okay. If you want to plot the graph, I mentioned just now, you can write this script. Okay, write this command, plot bracket CP comma T. Okay, enter. This will appear. Okay, this figure will appear. Or you can use this tab plots. Choose this plot. Okay, plot function. Okay. After you select the variables, okay, CP and T. Okay, so there's two ways. Okay. If you don't know the function, you can just look this step, and there's many functions that you can choose which one you want. Okay. So this I show this as just example. Choose this plot function. But if you look to this axis, okay, so this one is temperature, right? This one is the value for temperature. Now the y is temperature, T, and the x-axis is the CP. Okay, but we want the x-axis is temperature, right? If you want the x-axis temperature, and the y-axis is CP, or the heat capacity. So you just click this switch button. Okay? Just click this switch button, so it will change to T and CP. So this happens because when you select the variables just now, if you click the first one, the first one will become X axis. Okay? The second one will become Y. Okay? So this maybe first you click CP, and then after that you click T. Okay? Hold the shift button, click CP T, and then enter. This will happen. Okay? So I want to change the axis. So just click this switch button, and it will change to T and CP. So this one, you will have this graph CP versus T. Yeah? CP versus T. You have this CP and then T. Okay? Right. And you see here, when you use this function, it will automatically write the function in your command windows. Okay? When I switch just now, so it automatically this command appear in my command windows. And this figure one also change the axis. Right. This function, this one I use function plot, and later we can change this. If you don't want to have this line, we can change to only marker. Right. You can share only marker here. If you want, you can change this line to marker or to different type of line. Okay? But now I want to change it to only show the point using marker. You know marker, right? Using point. You have -50 and 100 and 1,250 right here. So this point and then the next point. I just want it to show the point. We can edit this one. But we also can use this function. Okay? Someone asked question. No. Okay. Right. You can edit this, or you can choose another function. Okay? I see here we have scatter. Scatter here, if you open MATLAB now, and then if you browse your mouse on top of this function, it will shows the helps box mention what this function will do. Okay, let's say you want to have this plot using this function scatter. So just click this one, and this will appear. Okay. So you see, after I click the function scatter, so in the command windows, you will also show this command. Okay. So I change from line to plot this point with only point or marker, okay? Because I want to have this type of figure, because I want to fit with a curve later. Right? Okay, now we have this figure, okay, with this plot. So we want to focus on this figure one. Okay, you can change everything here by writing command in the command windows. Okay, but if you don't know how to write the command, okay, so we can use this figure one. Okay. So let's I maximize this windows. Okay. So this figure one, we want to focus on this figure one. We try to avoid write too many code or too many script, right? Because I think some of you, it's the first time using MATLAB, or maybe first time do programming, because of this pandemic, COVID-19. Okay. So in this figure 1, we can add some more in this figure. Like this one, you can insert X label, Y label, title. Of course, you can use some commands. You can write the program to have this X label, Y label. Okay, but you have this function, right? We can just use this one. So you just click X label, Y label, or title to add in this plot. Let's say I already click X label and then I type the label for X and then Y and then the title. Okay, so just click that one. So you can have something like this. Okay, when you click the X label, so there's appear down there. You can edit. You can edit. You can type this temperature T and then you click the Y label. Okay, then you can edit. You can put your own label for the Y axis and also for the title. Okay, so just use the insert button there. Okay, no need to write command. Then what you want to do? Next one, okay, you can change this marker. If you feel this marker is not very clear, you can change the size. You can change the color. Okay? By right click. First you have to click this. You have to click this edit plot. Okay? This arrow is to edit this plot. You have to click this one, and then you right click the marker, so this will appear. Okay? This message will appear. You can change marker face color, marker edge color, right? Or you can change the marker type, right? Or you can open the property inspector. Okay? After you click this one, open property inspector, or also you can click this tool. This one is also the property inspector. Okay, you click this one or you click this one, something will appear. The property inspector will appear. Okay, this one. Okay. All right. Okay, this property inspector will appear, and you can change the marker. Okay, you can change one by one by right click, or you can use this property inspector. Okay, and you can change many things in this property inspector. Right? So let's say I use this property inspector. I change the marker. Maybe I change the color. I change the color. This color. Okay. This color of. And also I change the size, the width size. Then I have something like this. Okay. So I change the color and the line become slightly thicker. Okay. Change to 1.1. Okay. Previously 0.5, the size, the width size. Okay. So I change to 1.0 now. Okay. And also change the color. So to me it's better now. Okay. Clearer than previously. Okay. All right. Okay, after that, what we want to do? Yes, next one we want to do this curve fitting. Okay. We can use this figure as well. So you can click these tools, and many things you can do in these tools, but the important one for this data analysis, this one, basic fitting. Right? So see in this figure, Windows, there's a tools, basic fitting. You can just click this basic fitting, and this window for basic fitting will appear. Okay. Of course, there's a function, there's a command, if you know, like polyfit, polyval. You can write the script to do the fitting. But this afternoon, I show you can do the fitting without do the coding, right? Write the complicated program. Okay, so there's many type of fits you can choose, okay, to fit this data. You can click linear. Okay, let's say I click linear, okay, and I click want to show the equation and R square. You know R square, right? Okay, so I have this fitting, okay, with this equation and R square. Okay. You can see this one, how accurate or how well this line can fit all the data. Right? Okay. Oh, I can change to, because this one is 0.969, 0.97, the R square. So maybe I want to change. I can change this quadratics. You can change. You can click more than one, but then you will see more than one line here. So I want to. I prefer to select one by one. So let's say I click this quadratic. I remove this linear. Okay. I have this fitting, this quadratic fitting. I have this curve. Okay. This curve is a quadratic curve. Okay. X power 2. Just now only x. Okay. Now we have this x power 2, 0.01. Okay, the coefficient for x power 2. And R square, the R square is slightly better, 0.99. Okay. Right. So perhaps you can choose this one as the right equation. Yeah, that's the best equation. Okay. Or you can try another fitting slightly higher. You can try this cubic. Okay. Now I click this cubic. Remove the quadratics. So you can see, okay, it fits almost all the point. And you can see the R square is almost to 1, 0.99. But you have more coefficient, okay, x3, and also the coefficient is very, very small, 0.0001. Okay. So it's up to you which one you want to. If you feel this will not be too significant, okay, you can remain on the quadratics, or if you prefer this one, you can take this one. Okay. So let's say you take this one, this cubic, and then okay, I maximize this, and I'm satisfied with this one, and I can save the figure. Okay. Let's say, for example, I want to put in my journal paper. Okay, in the results, or in the discussion. So you can save this figure. Click this save figure. Okay. So before that, I can make it this size of the X, and also the title, all the labels, okay, slightly bigger, okay, to put in my articles. Okay. You can just choose the, or you can just double click this title label to change the size, and you can save it. MATLAB figure, click save button, and then you can save MATLAB figure. Put, and it will save. It will show your current folder. If you just save it, then it will put in your current folder. Okay. So that's why it's important. You need to know where is your current folder. Okay. Or you can change where you want to save the figure, in desktop or in download folder, for example. Okay, and then you can insert in your paper. Okay. Right? Can you follow? Okay, up to now, okay. Or am I too fast? Okay. Right. So this how you have your figure, right? After you do this fitting. And let's say you want to share with your friends how you do this fitting. You can share the script, even you not write the script. You can share the script, you can show to your supervisor, something like you write the script. Right. Let's say how to write this script. Okay. You have this command in the command windows. Okay. All these command windows. And if you look at this side, okay, you see the command history. Okay, the command history will keep any command you type in the command windows. Start from the day you install the MATLAB. Okay, if not delete the command windows. Okay, in the command history. Okay? If you remain, you let everything in the command history. You not delete. You can delete in the command history. But if you after you install the MATLAB, you just write the Khalifa. Oh, okay. Okay. Just if you type any command windows, it will store in the command history. If you cannot find the command history, okay, let's say if you open the MATLAB, you only see this tree. Okay, you only see this current folder, workspace, and command windows. Without this command history button, okay, or tab here, you can search the command history in the layout. Right, you click the layout, and then you can see the command history there. Then you can click the command history, okay, to appear in this layout. Okay. So I click the command history. Okay, so it will shows all the command that I have typed, okay, or I have created before this. Then I can choose which one I want to put in my script. Right. You know this one is working. Okay. T, okay, this script TCP, and then plot or scatter. Oh, okay, I choose this three, T, CP, and scatter. Then I right click. Okay, I right click and I choose create script. Okay. Hopefully you can see this, because this one is my screenshot, right? I know when you see in Webex, it comes small, right? Okay, turn to the full view. Okay, hopefully you can see this. Create script. Okay. After you choose this, all the command that you want, then you create script. Okay, right click what you have select, and then this will appear, and then you click this create script. Okay, when you click this create script, this editor windows will appear. Okay. This editor windows, actually, if you want to write a program, okay, write a script or a function file, you have to open this editor windows. Okay. But it's not our intention for today, right? All right. But I just want to show you how you can transform from the command history become a script. Okay. So just now you select the command in the command history, and then you right click, and then you click the create script, and then this editor window appear with the script you select. You have select. Okay. And you can save. So just click this save button. Okay, save, and then you can add some comment, okay, using this percent symbol. If you use 1% symbol, this one I use double. If you use 1% symbol, it become a comment. Comment means MATLAB will not execute that line. Okay, but if you use double percent here, it become a section. Okay. You see here I have 2 sections. First section, data, temperature, and heat capacity. So this is my data. And then I have another section to plot the data. Okay, this one. I put double percent symbol. Okay. You can see here you can insert comment using this percent symbol, or you can put in section like this. I decided to put in section. Okay, this save just now as this my CPV BST. Okay, .m. Okay, so I have this simple script, and then I want to share with my friends or with my supervisor to show my progress using MATLAB. You can click publish. Okay. This is the another tab when this editor window appear. Okay, before that you only have home, plots, and apps, right? Okay, when this editor window appear, you have another 2 tab, publish and view. Okay, so I can publish this. You click this tab, publish, and okay, publish, and here you can choose publish my CPV ST. You can publish the script, okay? Or you can edit. Okay. Okay. Let's say you want to publish. By default, if you just click this publish my CPV.st, this file, by default it will publish in HTML file. Okay. HTML file. If you want to change the type of file, you have to click this edit publishing option, and then inside there you can change to, for example, PDF. If you want to have PDF, you can change to PDF. Okay. Okay, let's say you just click this one. So this will appear. Okay. They will be appear in your current folder. Okay. You will have this file and then also the HTML folder, okay, in your current folder. Okay. So you will see this. The section become like menu. Okay. Content, and then this you can click this, and it will show this one. If you have long script, you have select many commands now. Okay, and then I put double percent just now. can it become a section, and also after you publish, it become this simple menu. Okay, this if you click this plot, it will show this plot data. Okay, and you see here, because you click this scatter, okay, you'll show the one without the curve fitting. Okay. This one before we do this curve fitting. Okay. Whatever you do in the figure windows, it will not appear in the command windows. Okay. Whatever editing you did in the figure windows, you use the menu insert, now tools, right? So it not appear in the command windows. Okay. So if you want to have figure with the fitting, okay, so you have to go back to the figure windows. Okay. This one okay. This one okay. So okay, right? Okay. Right. Hopefully we have enough time for the exercise. So you have to go back to the figure windows. Okay. This one figure window. I not close this figure windows. Okay. This is my figure window just now. In the file menu, you have this generate code. Yeah, file, edit, view, insert. Just now we use these two menu, right? Insert and tools, right? You can, okay, you look under this file menu, generate code. Okay. So you can click this, generate code. Again, the editor window will appear. Okay. Click this, generate code. Editor window will appear. Okay, with this function. Okay. So you don't need to write the code, MATLAB write the code for you. Okay. But of course, if you look this code, if you look down there, it's likely a bit complex. If you in the level beginner, never mind. You can if you anything that you not understand, you can right click like this one. Exists. Okay. Function, you can right click and it will have this help menu. Okay, but the important is you have this code, you have this programs, something related to your curve fitting just now. So you can change this name. By default, it will create a function with this name, create figure, and also this two input. Okay, x1, y1. You can change this create figure, but if you change this create figure, let's say you change to my figure, when you want to save the file, you should save my figure. If you change to my figure, okay. Let's say you not change this name. Okay, this one we not yet save the file. Okay, so you can click this save icon, and this will appear. Okay, with this by default this name. Okay, if you create a function, you should name as same name with the function name. Okay, this by default MATLAB create this function with create figure. Okay, the name of this function is create figure. When you save, so the file name should better have the same name. Okay, and this MATLAB suggests for you, because you have the name of the function is create figure. So just click save here, right? Click save, and you have this create figure.m, right? Okay, now we can use this function. Okay, in the command windows. Okay. You have this function related to the one fitting you did just now. Okay. Okay, just like I clear the windows, the command windows. you can use clear command here, okay, to clear the command windows, clear command or CLC. Okay, if you know you're not already about MATLAB, you have to clear the command windows, CLC, and clear command. Okay, and you type the create figure. Create figure. Someone asked.
Excuse me, Doctor.
Yeah.
Okay, there's an important question. The participant asked that, can you copy the code here?
Nabila. Okay, Nabila, you ask, can you copy the code here? Where? In the chat?
Yeah, the question, yes.
The code? Which code? The one the MATLAB code, the one the MATLAB generate?
Okay.
No, don't worry about that one. Okay. You want that code, right? Never mind. You can edit like what I edit just now, and then you can generate your own code. Okay, you can generate after you do your fitting, and then you can generate the code. Okay, so don't worry about that one. You just follow the step I did just now. Okay, right? This one I just show you the example. Because just now I feed only with linear and then third order polynomial. I feed with third order polynomial. If you use that code, okay, if you use that code, you will fitting your data with the polynomial third order. Okay? So whatever I show you just now, maybe it's not it's useless. It's useless for you. It's for example only. Okay, you maybe you want to fit with the quadratic or with more or with a higher order. Okay? So don't worry about the code. Right. So let's say we have create the related code just now. Okay, then create figure. So this create figure will fit your data with polynomial third order because we save just now. Okay, I go back to my slide. Okay. 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 So before I generate code, okay, I have this fitting. Okay, I fit my data with polynomial third order. Okay. Then when I generate code, so this code is only only to fit the data with polynomial third order. Okay. But maybe you want to have we are the second order. Okay. It's not a general code for any fitting. Eh? Okay. This one specifically related to what you have done. Okay, so I can recreate the figure just now using the same data. So create figure. So bracket, and you will see this apps message. So x1 and y1. Okay, okay, you know that your x is t, right? And then the y is cp. So you just click. You can click these two variables in the workspace, and then you can write if you want your x will be t. T is your x, cp is your y. So you have to click a t first. T, you hold shift button, T and CP, and then you drag to here. Okay, you drag to here to this bracket, and then you release. Then this will appear. Or you can type, right? You can type T, CP, right? Okay, you can drag to here, or you can type T, CP. Right? If this one useful if you have many variables, for example, more than 4 or 5, right? So you can select, and then just drag here. Okay, and then you can enter. Then figure windows will appear. Okay, And then you do the same process for the publication, okay, for the documentation, and then you can have something like this, right? I select TCP and I select create figure, okay, in the command history. Okay. And when I click publish, so this will appear in HTML file. You also can have this in PDF file. You have to change before you publish. You have to change to PDF file. Okay. Anyway, I can show how to change that to PDF file when after I finish this. Hopefully, I can share my MATLAB. Okay. For now, I want to shift MATLAB slides. I don't want to confuse. Okay, no one. So clear, right? This one. Okay, so we have fulfilled all the CLO, right? I don't know whether you can do it or not. Okay, we can have exercise for this. So that one is using only plot. We have tab plot, right? Okay, we have this plots, right? You use this tab plots. We can choose the function to plots, okay, the variables, and then we can edit in the figure windows, and then we can do the basic fitting. Then you can publish something like this, or you can get the figure to put in your journal article. Right, so far okay, right? Okay, let's move to the next one. Next one is apps tabs. These apps tabs. Just now I show you you can use the function in the plot tabs. Now you can also do this analysis without complex programming. Okay. Don't worry about the coding. MATLAB will create for you. You can use this curve fitting tools. Okay, under these apps, curve fittings. So if you want to use these tools, it's important when you install the MATLAB, during the installation, you select these tools. Okay. There's a step during your installation. You have to choose tools, which tools you want to have in your MATLAB. So try to find this curve fitting tools, because this is very useful for this analysis to do this kind of curve fitting. So if you already include during the installation, you can use this curve fitting. If not, you can install this tool. Okay. After the installation, also you can search in the MathWorks, the tools, and then you can download and install. Okay. It's not a very difficult step to install this one. Okay, so I want to show you how to use this curve fitting tools with the same example, case study 1. Okay, what's time now? We have 4 case study, right? Okay, case study 1 still under case study 1 using curve fitting. Okay, you can use this. Now you have these 2 variables, right? CP and T. Okay, you click this curve fitting. Okay, without click these variables. Okay, you click curve fitting, and this windows will appear. Okay, this window for the curve fitting tools. Okay, there's this is a name tab for the names of the fitting. then your variables or your data, and this the type of fitting you want. Okay, so we have our temperature is our X data, right? And the CP is for our Y data. So we can select here. You can change the name first. I change the name and then I select T for my X data, because when you click here, okay, I change the name to poly2. Change the name poly2. Then I click this X data. So it will show the variables we have in the workspace. We have CP and T, right? So I choose T for X data. Then for Y data, I select CP. Okay, TCP. I have this name poly2, and because I not remove the auto fit. Okay, by default the auto fit is tick. So by default it tick. So after you just insert the variables, after you have select the variables, it will auto fit for you, okay, with this polynomial fitting. Okay, so it by default it will fit with degree 1. Okay, for this case it will somehow this tool it analyze automatically your data, and then it suggests this polynomial fitting, okay, with degree 1. Then you can change. Okay, the result, you can see the result here. Okay, this one the model, and then the coefficient for the x power 1 and x power 0. Okay, and then this one, how well is the line, there's this linear line fit the data, and it showed here r square 0.969, similar to the one we have before this in the figure windows, right? We use the basic fitting. Okay, and you can change. You know, degree 2 or degree 3 is better, right? Can fit better this data, so you can change this to degree 2. Okay, and then you will see this, because when you change to degree 2, because this still tick auto fit stick in on the spot, change the curve. Okay, it totally change this plot. So with this curve, and also you will see this result and the equation, right, and all the coefficient, and actually it is the same value with the one we have before this, using figure windows. Okay, basic fitting in figure windows, and before this we have okay, we have this degree 3, right? So we can change to degree 3. I think I change to degree 3. No, okay, I remain with degree 2. Okay, so you can change to degree 3. Okay, you also can see how well this curve fit with your data. You can check the difference between the point and the data. Okay, so you can click residual plot. You can click residual plot, so you can see the difference from your plot and the curve. So it will show you the different value, right? I question, there's question in the chat. How about for non-linear?
So, Doctor,
Yeah.
Yes, Nabila is asking that how about for non-linear regression? Is it the same?
Yeah, what we did just now is this one is not, actually is non-linear regression. Okay, what I showed you just now now is linear regression. Okay.
All
Is
right,
it okay, Nabila? Is it the same? How about for non-linear regression? Is it the same? Yes. Now it's non-linear. So you can change if linear. This one. Another question.
There's another question. How if we have already?
How if we have already have? Okay, okay. Don't worry about that one. Okay, we'll almost four now. Okay. Yes, I will answer your question later. We move to the next case study, right? This one we only we start on this case study one. We have 4 case study. Don't worry about that one. Okay. So this one we don't know the formula, so we fit with the polynomial. Okay. So you can change the degree of the polynomial. So if you want the linear line, you degree is 1. If you want to have the non-linear regression, so you can fit with the degree more than 1. Right. Then this one I just show you this residual plot, right? So you can see the different the data with your plot, and so you can have this. Okay, this polynomial. This one for second order. The next one. All right. I can copy this if I want to compare with let's say I want to have second order and a third order. Okay. I want to do the comparison. So you can duplicate. You can right click. You can go down here. This fit name poly2. You right click this poly2. You can duplicate this poly2. Okay. So duplicate. Click duplicate poly2. And then it will appear this tab and also this name poly2 copy 1. Okay. And then you can change this. I change this to poly3 because I want to fit with the degree 3 polynomial with third order. Okay. Poly2 polynomial second order. Okay, I want to make the comparison. So I change it to poly3. Okay, the variable is the same. And I change the order to 3. Okay, the degree to 3. Then I have this result, and this the residual plot. Okay, and also I can change this view up here to side by side or top and bottom. So I can change the view side by side. I have this one about polynomial second order, and then on the right side is polynomial third order. Okay, so I can make comparison, right? Okay, the results and also the fitting. Okay. And down here we have the fit name and with the data and the fit type, everything, right? Okay, and I also can change the view like this, right, to make the comparison. And then let's say I want to have this poly 3, I think. Okay. Oh, I prefer with poly 2, right? Maybe because of if we have poly 3, the coefficient is very small, and you can see the confidence bound. Okay, how confidence, okay, with the fitting. Two coefficient is it cross the 0 axis. Okay, we don't want that one. So I prefer this poly 2, so I can save can save this poly2. You right click the poly2, save to workspace. Okay, down here, save poly2 to workspace. So when you click that one, this box, dialog box will appear. And I just want to save the model. I name it as CPT model. Okay. So I change the CPT model. By default, the name is fit model. Okay. So I remove these two, untick these two. I'll tick only this one because I want to have only this model in my workspace. Okay, and then I click OK. And in my workspace, this object will appear. CPT model. This one is not functional. This one is object. Yes, object. Okay. And then you can use this to do the calculation. Like this one. Let's say I want to get the value of CP when the temperature is 30. Okay. So I can use this model, this object CPT model bracket T. Okay. Because inside here is our X, right? So I will get the value of CP when temperature is 30. And also if I want to get the value of CP when temperature is 150, so I'll just put this one like this. I have this variable CP 150 equals to this model, CPT model, and then I will have the value, right? Okay, and this one, just show you some simple script. Okay, you can use this to plot the fitting. Okay, this simple. Or you can use this plot. Okay, if you not use this plot function, you have to do this like this. Yes.
You know, I number of upload.
Yes, yes.
Hello.
Hello.
Go on, Doctor.
Okay.
Okay, I think there's a question. It said how to get the model to the command window.
How to get the model to the command window? Yes. This one, right? Hold on. How to get this model, right? CPT model, right? You have it in the workspace. So just type there. Okay. If you type the CPT model, okay. I think I have in next slide. Okay. If you type in the command windows CPT model, you have this CPT model in the workspace. You type CPT model, enter. It will show you the model, the equation, and also the coefficient. Okay. It will show you this one. Okay. It will show you this. Okay. Or this one, poly2, right? Okay, you show you this one because I save it as CPT model. Okay. So if you want to apply it, you just type that one. I have these variables CPT. You can name any variables to store the value of CPT model at 30. Okay. Let's say you can type A equals to CPT model bracket 30. Okay. Then you will have A equals to this value. And of course, inside here, you also will have the variable A, okay, with this value, right? So you just type CPT model in the command windows. Whatever you have in the workspace, you can type here and enter. It will show you the space. For example, the CP, you type CP and then enter, it will show you the variables, the value of the CP. Okay. Right. It's 4 o'clock now. 4 o'clock? Not yet. 5 minutes. Right. Okay, this one is what happened if you not use the plots or a plot function. you can create the fitting with this CPT model I have just now. I can write this simple script to see the fitting of this at t equals to 30 and t equals to 150 together with the curve, okay, with the quadratic curve, right? Okay. This is how you have to do if you not use the figure windows. You can edit this in the figure windows, okay, without this program. But also it's convenient if you can write simple coding like this, okay, to show or to have your want to move this. Okay. Okay. If I write simple script like this, so I can have this plot, okay, with the one I calculate just now, CP at 30 degree, okay, maybe degree Celsius, and also at 150. So these two value I estimate using the model. Okay. You can write this simple script, then you can have this. Okay. Right. You want to know these details, then we can have another class, another session, how to write program using MATLAB. Okay. Next one. Okay, case study 2. Yeah, I hope I can finish this one. So this one, siapa yang tanya tadi? Who asked me just now? Nabila Huda. Okay, you have this equation, right? This. Okay, we finished the case study 1, right? Okay, this one, someone asked me if we have the equation, and how can we identify the coefficient, the right coefficient. So let's say you have something like this, you have problem something like this, you change some materials in your experiment, so maybe your model is slightly different, okay, with this previous study. Okay, let's say this one model from the previous study, then you can change the material, or if you refer to this case study, this one about organism decay, okay, in the lake water, this equation, and we want to know the value of this A, B, C. So we have this data. So how can we estimate the value of A, B, C? That can fit this data, right? And for this case, we have the data in text file. So case study 1, we have in the hard copy. We have in, let's say you have in the logbook. Now this one you have in the computer, but in text file. We can open using Notepad, Word file, or any word editor. And then this is your data. You already put like this, okay, in vertical. Okay. So you have to put in this vertical form in order to load to MATLAB. Okay, you have this data with this name, organism dashboard. Okay. So now how to load the data? Okay, before this you have to type. Now you have in text file. So in order to load the data, the text file, you can use this import data. Okay, in this home tab, you click this import data. Okay, click this import data, and if your file, the text file, in the current folder, so easily for you, you can see this file. You just can select this and then open. If it somewhere else in the desktops or in picture or in other folder, then you have to search. Okay, you have to search your file. Okay. So that's why this current folder, if you know the current folder and want to run MATLAB, put everything in the current folder. Right? So easier for you to do the analysis or to do any programming. Then you select this file and then you click open. Okay, when you click open, this window will appear. Okay. Okay. So this, you see this output type. If you just okay with this, if you click this import, okay, MATLAB will load this data in table form. In table form with the name of this organism pop in the workspace. Okay. And the variables is time t and population p. Okay, if you import like this, you want to read the data, you have to type something like organism pop dot time t if you want to have this data. Okay. Right, when you click import data, MATLAB automatically identify the value that it can import. Okay, they identify the cell where has the value it can import. Okay, you have here importable cells. Okay. If you have something like this time t population, if you want to include, okay, you need to click this and then you need to do something here. Okay, let's say you satisfied with this one. Okay, with this data right, you want this data right. This is our data right, 0.5 until 9, and also this one. Okay, but I don't want to import as a table. I want MATLAB import it as a variable, so easier for me to just select that variables later. Okay, so I need to change this table. I need to click this one. Okay, and I choose this column vector. Okay, this is how you want to have all this value in this column, and this column, these two column. MATLAB load it as a value of a variables. Okay. So I click this column vector, and then it will show this variable's name. You select this row 3. Okay, this is the variable name, time t and population p. Okay, it refer to this row 3. Okay, and it show here is the name of the variables, time t and population p. Because we have this in row 3 time comma t, right? So we cannot have that variable something like that. Okay. So let's select this, choose this time t and population p as the variables that has this value from row 4 to row 12. Okay, if you're not satisfied with this the name, This is name time t. Okay. You can change. You can double click, or you can click this one. Right? Okay. Okay. I already click time. Okay. T I change to time, and the population I change to population. Okay. Population p before this, right? So I change to population. So then okay. So I change the name of the variables to be in my workspace. Okay. In the MATLAB workspace, and then I click import. When you click import, this window will not close, okay, but it will show this. Okay, the following variables were imported: time and the population. Okay, and time and population. Okay, these two variables. Okay, and you can close this. Click this X. Okay, you can close these windows, and you can see in the workspace you have these two variables: time and population. Okay, with the value. Okay, with the value from our file organism pop. Okay. Okay. Clear how to load the data from the TXT file and become a variables in our workspace. Okay. It can be in table, but then you need to know how to read the value from that table. I don't want to show that one. Yeah. So I just want to show this one. Okay. Variables. It's easier to have this kind of form straight away in the variables. Next, you can use plots, but we know we have these apps. Okay, we have these tools. So you click curve fitting, right? And I change the name to pop fit. Okay. I click the curve fitting tool. This window will appear. Then change the name fit name to in. Someone asked in the chat.
So there's a question in the chat. The participant
Can one
asked
be
that
in
must
Word
the
or PDF?
document be in a Word or PDF?
Okay. It's better in text file in PDF. You can try. I never tried this PDF. I'm not sure about PDF, but the Word file or .txt is okay. But it better you put in your data put in vertical form. I'm not sure about the PDF. No. I never tried about the PDF. You can try if like cannot read, then you have to change it to Word file, because MATLAB can upload. If you cannot read, maybe it will upload as a figure, right? So you can try that one. But if you want to it upload as a view as a value, so you have to change to Word file or Excel file. You just transfer the value. Okay. Right. So you have okay, I changed this name pop fit, and then the X data I have time, and then Y data population. Okay, this time I remove the auto fit. Okay, before I select the variables, I remove the auto fit. Remove the auto fit. You can remain auto fit. Okay, tick, but then you can change the custom equation. Okay. But I want to type first the equation here, then I will select fit. That's why I remove the auto fit. So this is how we, if we have the standard equation, we just want to see what is the right coefficient. Okay. We know this data can fit with this model, but we want to know the right coefficient in that model for this data. So you can use this custom equation. If you click this, you can see not only this custom equation, you can see the polynomial, power, exponential, a lot of fitting you can select there. Okay, and okay, what I show you now is this one is just is specifically to our case study, right? Okay, so our case study, we have the question. You want to know the coefficient A, B, C, right? So I click custom equation, and then you have this y equals to x. So you need to change here the equation. By default, MATLAB will suggest one or two equation. Okay, so you can follow this, or you can edit this. I want to edit this one because the case study is okay, the equation not like this. Okay, so I change the equation according to the in the case study.
Okay.
Yeah. Any other
Load
question?
this.
Let me see. Okay. No. Right. Okay. So I changed the equation as in the case study. Then I click fit. Okay. This one I have the data. Okay. Without the curve, without the fitting, right? So I click this fit. Okay. So MATLAB will create a curve according to this equation. Okay. So you can see how well it fit the data and show the results. Okay. So you have your A, B, C. Yeah. Right. This is the value A, B, C, 4 point something, 2 point something, and 1 point something. Right. Curve fitting tools is it on MATLAB? Yes. During your installation, you have to select that one. If not, you can go to the MathWorks website and then search for that tools. Then you can download and install into your MATLAB. Okay. Right. If you click the apps tabs, you don't have the curve fitting tools, so you have to download it and then you have to install it. If you know you're not yet install MATLAB, and then during the installation, so in the step you can select the curve fitting tools, right? So you have the value A, B, C. Okay, don't worry about this confidence bounds. Okay, looks okay to me. And also this R square. Okay, 0.99. So yeah, that's it. You have the equation, and also here you can right click pop fit if you want to download it to your workspace. Next slide. Yeah, you can save it in your workspace. You right click, and then save to workspace. Okay, down here. Okay, before that, this one will appear. So I don't want to have this information anymore. Okay, this two. Oh goodness, okay, of the fitting. I just want to know. I want to get this model. I name it as pop fit model, and I save. Okay. Okay. So when you go to the this layout, the MATLAB layout, okay, you will see the command windows variables have been created in the base workspace. Right? Actually, this one, pop fit model. And if you want to see the equation, you just type the pop fit model here after the prompt. Okay, you type this pop fit model and then enter. So MATLAB will show what is it. So MATLAB will show this pop fit model. Okay, with the bracket and the equation related to this model, and also the coefficient. Okay. So since our case study, right? So we have this A, B, C, and we can do whatever we want to predict the value or to do any other operation, right? So we finished case study 2, I think. Right. Next, case study 3. Example 3. Okay. Is it okay? Case study 2. Right. Okay. So case study 3. Okay. This example. We have this situation. Okay. We have three variables, but the two variables it relate to the other one. That is this. So this one we have speed, thinking, and braking. So the distance. Say this one. The distance to stop the car for this one. Okay. The following experimental data were collected to quantify this relationship. So the blood-based field equation. Okay, for both thinking and braking component. Okay. The distance required to stop in order to consider both thinking and braking component. Okay. Each of which is a function of its speed. Right. So this speed actually is your y. Yeah. Okay. Not really your y, but it depends on yes, on these two taking. Okay. The distance depend on the relation of the speed with the thinking, and also the speed with the braking. Okay. It's not the model you have y equals to, or speed equals to thinking plus plus braking or multiply with braking. No. It relate with two separate function. Okay. Combinations. Which is function of its speed. Okay. You have two relation, okay, to get the distance to stop the automobile. Okay. You need to get data from two relation, two variables, two relation of variables, speed and thinking, speed and braking. Okay. Let's say you have this kind of situation. Okay, okay, and this for this case study, I have this data in Excel file. Okay, I have speed, thinking, braking. I already put my data like this. Okay. Then how to load this data from the Excel file? Okay. Same thing. You can use the import data, or you can double click this file. The file is stop distance. I have the file name is stop distance. Okay, for the case study 3. For Excel, you can double click or you can click the import data. Okay. If you double click or you click the import data, same window will appear like this. No. If you double click the stop distance cell, this window will appear. Straight away, this window will appear. If you click the import data, you will see this first. Then you have to select stop distance. Okay, and then click open. Then you will see this window. Right? Okay. Special for Excel. For Excel file, if you double click this file, Excel file, straight away you will see this window. Okay. You don't need to select the file. Okay, after we have this same process as case study 2 just now. Something. Right, same process. I don't want as a table. I want it as a variables, variable speed, thinking, and braking. If I click this, it will load as a table, stop distance. Okay, table. The name of the table is stop distance, and then it has these three heading or three row, three column with this value. But I don't want that. I want straight away become a variable. Same thing. I click this arrow, okay, and I change to column vector. Right, change to column vector, and MATLAB will load this column with as a variable speed. Okay, this variable speed will have this value, thinking with this value, braking with this value. Okay. And I click import. Right, import, and it will mention the following variables were imported: speed, thinking, and braking. Okay. This one in matrix 6 times 1, 6 row, 1 column. Okay, so I can close this window and check my workspace. I have these 3 variables: thinking, speed, and braking. Now I can select the curve fitting. Oops. Oh, I select the plot. Okay, I select the plot. Okay, I select the plots for this case because it relates with two variables. It relates speed with thinking, speed with braking. It's not combined, the relation. So I want to see how it relates. So I click plots and I choose plot as multiple. Okay, this one. Okay. Plot as multiple. Yes. Multiple series versus first input. Okay. Just now for the variables, I click speed first, and then thinking, and then braking. Okay, I click speed, and then I hold this shift button, then click thinking and speed, and then enter this will appear. Okay, speed, thinking, and braking. Okay, so I choose this function. Okay, to plot as multiple series versus first input. Then okay, so I have this figure. Okay, so it relates braking with the speed and thinking with the speed. Okay. Right. The y-axis is the speed. And then the x-axis is the braking and thinking, I think. Let's see, next. Right. Then I can change the line. I want to have only the marker. Yeah. I only want to have marker because I want to fit with this plot. Okay, this plot with a curve later on. So change this. I use this figure windows. So I change this 2 line with this marker. Okay, using the property inspector. Okay, so the square marker is for the thinking, and then the circle marker is for the braking. Okay. So you can change one by one. You can select this line, change the braking plot, and then change the next one, change for the thinking plot. Okay, so I have this in the same process as case study 1. Right. So I have this plot. Okay. If you want to know how I get this, you have to go back to the case study 1. Then I use this basic fitting. Okay. So to fit the plot with a curve or linear line. Okay. So here I have data thinking for, okay, this one fitting for the thinking for this square marker. So I choose linear. Okay, a linear and show the equation. So I get the R square is almost 1, and I can see the fitting fit well. Okay, this data, and I can do the same thing for the breaking. This one you have to do one by one. Okay. Next one, right? Okay, I can interpolate to get any value. Okay, so I can interpolate at 110. Okay, just now I'm not sure how you can do this one. Okay, in this figure 1, in this figure window for the basic fitting, you can also interpolate, okay, to get the estimate data. Okay. X 110, so you can get this value for your distance. And then I want to check for the breaking. So I fit with the quadratics. Okay, I can see it fit well with the quadratic. All right, and also I can check what is the value at 110.
We have shortage of time, so we just continue on this call. Please introduce yourself. Just briefly tell us about yourself.
So please,
Okay.
all participants are advised to mute.
All right. So same thing for the breaking, I can get the distance. Right.
So when you enrolled in your PhD program?
So this is how I did the fitting.
When you enrolled in a PhD program?
Okay, I can also use this curve fitting. I can also use this curve fitting to fit this thinking, speed, and breaking. Right? Okay, I hope you understand what about this case study 3. Study 3.
Inshallah. And when you did your MS, and from which university?
So yes,
okay, so you mentioned 7-year experience. It's about teaching experience.
So for this curve fitting tools, I name it as fit thinking. For the first one, I want to fit the thinking. So I have data X speed and Y is thinking. So same thing, I can fit with a straight line. Also, I choose polynomial degree 1. And I can save fit thinking model. Okay. And then I can duplicate. Okay. So actually I duplicate. Okay. I duplicate because I want to have another one is for the breaking. Okay, I duplicate this. So change this one fit for breaking. Maybe it's almost 430, right? Okay, never mind. So same thing as the basic fitting in the figure windows. I hit this braking with the quadratic
Your
curve,
job at Rahim Yar Khan University, still you
and
are employed at
then I have
Rahim
this
Yar
result,
Khan, or you have already resigned or left that university? What is the
and then I can load the model for fit braking and then for fit thinking in the workspace. So the special with this curve fitting, you can load the model in your workspace compared to your
What is your
figure
in your PhD? Can you
compared
just
to
explain
the basic fitting in figure Windows. For the basic fitting in the figure Windows, you only can see the model, but you cannot load the model in the workspace. You have to write somewhere the model. For this one, you can load. You have fit for braking, fit for thinking. I have these two tabs, right? Okay, I think the same thing as case study 1. I can look at with two sides. First side for the thinking model, and the right one is for the braking.
If I ask you to pick
Fatima.
subjects, or which one are your favorite subjects or preferable subjects?
Okay, that one. Okay. So we have this for the thinking and braking, and then we can load the model into workspace. Okay.
And other than
Right click.
field structure,
Okay, right click the name of this fitting, for example, for fit braking and also for the fit thinking, and then
other than the field structure,
load.
any
And
other
then you can
subject that
change
you would like to teach?
the name of the model. I name it a braking model, and for the thinking, I choose thinking model, and then click OK. And then in my workspace, I have this two model: thinking model and braking model.
ठीक है, चलो ठीक है,
And then I can do any operation I want with that model. Okay, so I can choose this total distance.
सर मेरे लिए तो suitable नहीं है ये।
Choose this total distance. You cannot hear?
बोलना भी तो अच्छा नहीं।
कैपेबिलिटी भी होनी चाहिए क्या?
वैसे ऑनलाइन में ये था कि अगर मतलब किसी दिन इंटरव्यू है उसी दिन हम स्टार्ट करते डेट को सुबह बुला के देख लेते हैं।
Can we mute this Fatima?
I've private chat and
I think it's already finished, right? Or maybe you can mute all the participants.
वैसे इसको अगर हम फाइनलाइज कर लें फिर
एक मिनट की बात आपने चलो 3 मिनट से बात करना है तो बस आके करते हैं।
Okay. Can I proceed? Right, okay.
Yes, you can.
Right. Okay. If you're not really clear about the case study 3, I think. Okay. Never mind. You can look back. I will share this in the Google Drive. Okay. You'll see. You have to look back at the problem in this case study 3, because it calculates the distance based on the relation of the speed and thinking, and also speed and braking. Okay. So for example, this one, after I have the model that relate thinking and speed, and also braking and speed. Okay. I have to relate thinking and speed, then get the distance. Braking and speed, and get the distance. Okay, so there's two different things. Okay. So then I can calculate the total distance here. So I can have these variables: total distance equals to thinking model at 110, and plus this braking model 110. Okay.
information security.
So I get the total distance here. And then if I want to check the value of teaching model, okay,
तो मैंने fix
yeah.
किया है.
So I can check the value. So I can check whether the total distance is right or wrong, right? Okay, so I think finish this case study 3. Okay, so you can look back this. I explained in 2. Okay. This about this case study 3. So it relates speed and thinking and speed and braking. I think this here is the distance. Oh, the speed, and then this one the thinking, right? Okay. So I hope you can understand this. It can be done by using this function in a plot, okay, using this braking and also using this curve fitting tools.
अगर हम इसको पहले
For the
इस तरह से देख लें कि
basic
डॉक्टर्स का था
fitting
मेरे
in the
नॉट
figure
7 नंबर पे
windows
डॉक्टर हैं
is useful if you want to view the fitting. Okay. If you want to
पहले उसको देख
the
लेते ताकि
model
आइडिया
to do the further calculation, okay, better use curve
हाँ
fitting
उसके
tools.
इंटरव्यू इनका करवा देते हैं ठीक है इसको टिक कर देते हैं सेकंड टिक डॉक्टर है 9 पे सर
I think we need to finish earlier.
ये अब एलिजिबल नहीं थी 80 के लिए और लेक्चर में इंटरेस्टेड नहीं इसको क्रॉस
Okay,
कर
this one, last one, case study 4.
इससे डॉक्टर आने 15 पे इनका काफी लोग शायद ये भी विजिटिंग पे आना चाह रहे थे इनका भी क्रॉस ही कर देते थे
on that. If there's any question,
और इसके बाद 17 पे अब इनका ये सिर्फ तो कंप्यूटर इंजीनियरिंग पर
So
पीएचडी
let me do
सॉफ्टवेयर
this different thing.
कम हो गया ना
You have this data. It this one is dissolve of oxygen in water, but it depends on two variables. Okay.
लेकिन सर वो मतलब वो तादाद भी देख
It
रहे ना पूरी
depends
करनी
on
क्योंकि
the
अभी हमने एक
chloride
डॉक्टर किया है ना
concentration and also the temperature.
लास्ट पे
Okay. So you
38
have
और
something like
40 पे
this,
दो डॉक्टर हैं उन दोनों को भी
and you
इंटरव्यू
want to
बुला
feed the data with this one. Okay.
38 और
You
40
mentioned here you can feed with the third order polynomial for the temperature, and then linear for the chloride. Okay. There's something similar, right, with the case study 3. Okay. There's no, but this one we already have
डॉक्टर्स अवेयर हैं
this model,
वो तो है अब सर
and we
हमने
want
सिर्फ
to.
3 को बुलाया है तो अगर इनको भी फिर तो अगर इनको भी बुला
I
लें
can
जो
record it.
लास्ट वाले आप कह रहे थे क्वेश्चन मार्क वाला 4 क्योंकि सीट्स काफी ज्यादा है ना दो
Right.
सीट्स
Then after you get the right model, then you can
विजिटिंग है दो को हम बुला रहे हैं तो कम बता देते
for
ये
the
मैं
dissolved
ये
oxygen
कह रहा था ना कि बहुत कम हो
concentration,
जाएगी ना तो ये 4 डॉक्टर्स को
for the
बुला
chloride
लेंगे
concentration 15 gram per liter at temperature 12 degrees. We want to estimate at this condition. Okay, same thing. I have this data in.
इनको बुला लेंगे ठीक है
I have data in I think in Excel file, right?
पेज
Okay.
पे
But for this data,
बॉर्डर
you
लाइन
have
पे से उनकी बात
to
करें
change
बॉर्डर
Border
लाइन
line पे
slightly. Okay, in Excel.
सॉफ्टवेयर उन्होंने दिखाई नहीं थे अपने और
So you have to
सॉफ्टवेयर इंजीनियरिंग एंड रिक्वायरमेंट
you
इंजीनियरिंग
have to
बॉर्डर लाइन था इसलिए कह रहे हैं
set your data like this. Okay, you have to
देन
put your
14
data
पे
like
थे
this.
नेक्स्ट पे थे
Okay, to include this chloride
बॉर्डर से नीचे
concentration and temperature. So you have to arrange like this. 0 for 0 temperature and then 0 chloride. For the oxygen concentration is 14.6.
जो बॉर्डर से ऊपर 20 पे है
14
14 तो हो गया 13 14 हो गया ठीक है इस पे टिक कर
You cannot remove Fatima.
20 पे है नंबर बतूल
Okay, I think you can remove the Fatima.
बॉर्डर से ऊपर की कोर्स का पेज
Yes,
कंप्लीट था
that is the host of
नेक्स्ट
this,
मिस सादिया
Indian
22 पे
data from
डॉक्यूमेंट मिसिंग थे
and our private chat
No,
Fatima
we
is
did
not responding. So I don't understand why she is.
All right.
ये तो next आ जाते हैं. सानिया अरशद 25 पे.
इनको एक दफा चाल दे देते हैं ये होने का, ठीक है, ये भी
I
वैसे
think maybe we have exceeded the time, right?
ये है मैंने अपने आप
Yes, it's already 4:41. I was supposed to talk for 4:30 for maybe before that time.
ऊपर सर. Next sir पे 27
Okay,
28
Muhammad, can I proceed? Right. Okay, for this, you have this situation, we have to rearrange our data in Excel, something like this, so that it put the independent variables T and C, right? Okay. So change like this, then same process like case study 2 and 3. Okay. Right, you just double click the file. I think I double click. Yes. Yes. I have dissolved oxygen. Okay, in my current folder for the data, and so just double click, and then I will have this windows. Then I change to column vector so that this value will load into variable T, C. Okay, so this column to variable C, and this column to variable O2. Okay, I have this variable 3 variable T, C, O2. Okay. And then I choose this curve fitting tools. Okay, and I have this fit name, this of O2, and X data T, Y data C, and my Z data is O2. Okay, then I not remove this auto fit, so it automatically fit the polynomial using this polynomial degree 2. Okay. And then I satisfied with this one, so I right click this of O2, and then I save the model to workspace. Okay, I name it as this of O2, right, and model, and then click OK, right. Okay, I will give my email in the chat box later, right. Okay, then I have this model, so now I can use this model to determine the value, okay, at the T12, right? Chloride 15, right? T12 chloride 15. The true value is 9.09. Eh? Okay, I fit this model with just now with this second order. Okay, I get the value 9.1464. Okay, slightly higher. Then I follow the suggestion that the case study suggests fit with the third order polynomial for the temperature. Okay, I follow. Okay, for X I put third order, and then Y is 1. Okay, and okay, I have this model, so I save it as dissolve to model 3. And when I estimate with this model, I have 9.1515 is slightly higher. So it seems like this it's better to fit with the polynomial second order for the temperature combined with the linear relation with for this chloride concentration. Okay. Okay. So that's case study 4. So we have this exercise. I think I want to have this exercise. I want to have the volunteer, but already exceed the time, right?
Exceeded the time. So maybe doctor is going to drop his email so that
Yes, yeah.
for us to understand the session better, we are encouraged to, partake in the exercise and possibly submit it to you by your email.
All right, okay. Because I want to check
Because
whether I fulfill the CLO or not. I have prepared exercise.
but
I think 5 exercise.
maybe one person can volunteer. Maybe doctor can ask maybe one of the participants or two to volunteer.
If you want, if you can volunteer, this exercise. I have this until 5 exercise. Okay. Maybe this one, the simple one. Can have the volunteer to, you can share. Again, same again. You can share your MATLAB, and maybe you can try how to fit this one. Okay. Can we have that one, that volunteer?
Doctor is asking all participants if anyone is to volunteer to.
You can get, you can get 100. Can get 100 ringgit. Huh?
Okay.
100 ringgit.
Doctor is giving an.
No, 100
gift of
ringgit. No, 100 ringgit if you come to volunteer at the PVV. For the vaccine, COVID-19, one day, right? So for this one, you maybe get, I can give you 10 ringgit. Maybe it's because it's only few minutes, 4 minutes, so I can give 10%. 10% of the 100 ringgit of the volunteer for the COVID-19. Per day, right? That one is per day 100. This one only few minutes.
In the absence of no one yet, maybe there's anyone with a simple question for doctor.
Okay, I have this exercise and also the file because I have this exercise, exercise 1, exercise 2, in this, that mean the data in this exercise, not any text file or Excel file, but I have exercise 3, 4, 5 in text file or Excel file. So I can share with you the folder. I put already in the Google folder, and also the slide for this one. I think I stopped sharing this one. Okay, because I want to look at the. Because I want to look at my file. Okay. Okay, I copy link. Right. Okay, I share the link for the Google Drive in the chat file. Okay. So in that Google Drive, you have the slide and then the exercise, the PDF file for the exercise, and also the related file. Okay. Yeah, for the exercise 3, 4, and 5. Okay.
Thank you very much for that sharing. And additionally, for others, these files and other important information will be to all
my email. Okay.
Back form.
My email. I think Muhammad know my email, right? Cam.my. All right. Okay, this is my email.
Okay. So here in the chat box is doctor email for further maybe assistance after you must have done the exercise. You can send it to him for marking and for him to know you have actually understand, what he has taught us today. And we would like to appreciate, the time that you have spared with us today for this sharing session. And Lastly, I will also need to ask if there is any maybe short question for Doctor that will not take much of our time from any of the participants. Please, you have any short question, because we have already spent almost about 2.5 hours now. So if you have any short question, you can ask to Doctor. But in the absence of no question, I'd like to, as a sign of appreciation, there is a certificate of appreciation that will be given to Doctor for his time out today and for the wonderful training that he has shared with us. And here on the screen is the certificate of appreciation. And this is presented to our distinguished speaker, Dr. Saharudin Haron, on behalf of PGSC, School of Chemical and Energy Engineering Asia. We hereby present this certificate of appreciation to you. Thank you very much. And after this, in the absence of no question, there's going to be a photo session.